Hi, and welcome to another installment of Math Basics with Mr. Besh. Today we're going to talk about proportions, and what we're going to do is we're going to solve proportions using cross multiplication, and last but not least, we are going to set up proportions from word problem applications. By definition of math, a proportion is one fraction equal to another fraction. The key is one of the fractions has a missing piece, and our job is to find it. You find that missing piece by this technique, which is referred to as cross multiplication. Cross multiplication has a couple useful applications. For instance, if I have two fractions like you have here, all right, just like we see, two fractions. In mathematics, to determine which fraction is bigger than the other, what I can do is cross multiply. Cross multiply means you take the first fraction on the top, the numerator, and multiply it by what is diagonally across from it on the bottom of the second fraction. So you take 2 times 8, and 2 times 8 comes out to be 16. Next thing you do is take the top, the numerator of the second fraction, multiplied by the bottom of the first. 5 times 3 is going to give us 15. And now instead of comparing the two fractions, 2/3 to 5/8, we are comparing the two values, 16 to 15. And we all know that 16 is bigger than 15, so as a result, 2/3 is greater than 5/8. So this is how cross multiplication can be used to do some trivial basic math. But now it also is used to solve missing pieces of problems. Now I have a gamut here of mathematical word problems. I'm going to start out with some of the easy ones, and we're going to build up to some that require a little bit more critical reading. Here's our first one. $58 per day to rent a car. We want to find out exactly how much will it cost for 1 week. So when we're setting up, we take and we break this thing down. If it costs $58 per day to rent the car, my two labels that I'm using in the problem, my two variables, are cost and days. If it's $58 over 1 day, notice my fraction I make, 58 over 1. The top number of the numerator is the dollars, the bottom number is the number of days. This has to equal, I want to create a proportion and set this equal to another fraction in such a way that the second fraction also has a value on top that is dollars and on bottom is days. So now I read out the problem. The other number involved is 1 week. Now I want to talk about days. So I need to convert 1 week into days, which is 7. So 7 goes on the bottom, and every single one of your proportions that you set up here will have a missing term, a variable. And the way I'm going to teach you, every time you set this up, your second fraction, the fraction on the right hand of the equal sign, will have that variable. X will be either on the bottom or the top, depending upon the labels. So because my first fraction was 58 over 1, dollars over days, my next fraction needs to be dollars over days. And then what I do after this is I do cross multiply. I take my fraction like I have here, multiplying the diagonals together. 58 times 7 is going to give me 406. And then I take 1 times x, and I end up getting just simply 1x, or x itself. And now, as a result, this is my answer to the problem. The bottom line is, if it's going to cost me $58 for 1 day to rent that car, then if I rent it for a week, 7 days, it's going to cost me $406. And this is what I do. This is what I do. This is how I cross multiply. Another look with another fairly simple problem. 5 erasers cost $2.50. So those are going to be the two numbers that I use in my first fraction. Notice their labels, erasers and dollars. So my first fraction is 5 over 2.5, or 2.50 in terms of dollars. Now notice, the fraction created was erasers on top, dollars on the bottom. So now the second fraction I need, to the right of the equal sign, needs to have the number of erasers on top and the number of dollars on the bottom. Now I finish out, I read the problem. At this rate, how many erasers can I get for $7.50? The other number that's involved in the problem is dollars. So that needs to go on the bottom like dollars was on the first fraction. That means x again is on the top. So then what I need to do is take my fractions here on both sides and then solve my proportion using cross multiplication. So now, same thing, multiply the diagonals. 5 times 7.5 ends up getting me 37.5. And when I take 2.5 times x That's going to give me 2.5x. Now, unlike the last problem, this one requires one extra step. I got to get rid of the 2.5 in front of x. 2.5x means 2.5 times x. So the opposite of multiplying by 2.5 is dividing by 2.5. And remember from algebra, if I divide one side by 2.5 of the equation, I need to divide the other side by 2.5. 2.5x divided by 2.5 is 1x. And when I take 37.5 divided by 2.5, I end up getting my answer. My answer is 15 erasers for $7.50. Please note, my answers when I do a proportion will have a label every single time. And you need to make sure that you have a label for each and every single one of these answers. They all vary. Here's one where it's not a word problem, it's geometric shapes. In this math problem, there are two triangles. A lot of times people don't see the triangle inside the bigger triangle. All right? The bigger triangle that I have here has the following letters at the corner. P on top, Q on the bottom, and R all the way out on the right-hand side. But there's a smaller triangle inside there that has the letters S, T, and R. Notice the sides, notice the values. I can also use proportions to find a missing side of one of these triangles. I highlighted a missing side for you. The distance from Q to R. We don't know what that is. You see, I know the distance from T to R is 36. I know the distance from T to S is 30. I know the distance from P to Q is 38. But I do not know the distance from Q to R. And let's say I had a math problem where they were asking me, what is the distance from Q to R? So what we do is we take these two triangles, and if they are similar, that means they have proportions. Now, this is what this means in simplest terms. If I take the smaller triangle in mathematics, all three sides of it, if I multiply those three sides by the same number, as a result, I am going to create a triangle larger than that. And if I do that, those triangles are similar, and they are similar by proportion. They increase in size by proportion. So what I'm going to do when I solve this math problem is the following. I am going to take what I know. I know the height of the smaller triangle is 30. I know the base of the smaller triangle is 30 and 36. And that is going to be my first fraction. The height of the smaller triangle, 30, over top of the base of the smaller triangle, which is 36. So height of the smaller triangle over base of the smaller triangle. Now that needs to be equal to the height of the bigger triangle over top of the base of the bigger triangle. Now the bigger triangle has a height of 38, but the base from Q to R, I do not know what that is, so that's going to be x. So now in my fractions, I'm going to take 30 over 36, the height of the little triangle over the base of the little triangle, equals the height of the big triangle over the base of the big triangle. And then I simply cross multiply. 30 times x gives me 30x. 38 times 36 gives me 1,368. And now I got to get x by itself, so the opposite of multiplying by 30 is dividing both sides by 30. And when I divide each of these sides by 30, I get my missing base. The missing base of the larger triangle is 45.6. Remember, sometimes your answers come out to be fractions, sometimes they have decimals involved. It's okay, just get used to this. The last one I want to talk about is one that has a little bit more critical reading, and we're going back to word problems. At the beginning of a hockey season, the Penguins won 9 games and lost 4 games. At this rate, how many games would they win in a normal 82-game season? So here's how this breaks down. We want to know how many games would the Penguins win in an 82-game season. What we do know is that in the start of the season, they win 9 and they lose 4. The big picture, which usually gets lost for students, is the fact that they played 13 games, and that's a very important number in the math problem. If you win 9 and you lose 4, that means you play 13. So basically what this is saying is, for every 13 games, the Penguins are winning 9 and losing 4. So my first fraction isn't 9 over 4 or 4 over 9. My first fraction is the number of wins, 9, over top of the number of games played, 13. And then this is equal to the number of wins that I can expect or predict in an 82-game season, which is x, over top of the total number of games, which is the entire season, which is the 82 games. And then when I have this, and I get rolling, solving my proportion, 9 over 13 equals x over 82, and breaking this thing down, 9 times 82 gives me 738, 13 times x gives me 13x, divide both sides by 13, and what we can pretty much predict, you get a decimal, comes out to be 56.77. Remember, certain times it's acceptable to round, so approximately 57 wins would be my answer for this question, okay? This is proportions. This is solving proportions with the word problems, setting them up, cross-multiplying. The basic thing I want to tell you is take your time, make sure your fractions match up, label for label. The numerator of the first fraction needs to have the same label as the numerator of the second fraction, and the denominator of the first fraction needs to have the same label as the denominator of the second fraction. If you do this correctly and you take your time multiplying, then this should be a piece of cake. And this was proportions. I hope you found this both helpful and informative.